Okay, now we're going to do problem 9.1.13T. Same again, two proportions. So 2808 occupants not wearing seatbelts, 7,796 wearing seatbelts, 11 were killed, 36 were killed for the former. The percentage looks like it's going to be in favor of the first one. But at the 05 level of significance, test the claim that the seatbelts are effective in reducing fatalities. That means that P2 will be less than P1. In other words, P1 is greater. There's a higher death rate. The only one that satisfies that as an alternative is C, not letter C. So it's a right tail test, the Z statistic. So we go to StatCrunch. So this time we don't need a calculator because they don't give us percentages, they give us the actual values. So it's two samples with summary. The first one, see, they're calling a success being killed. That's a statistical success in a sense. I know it's awkward. And for the other one, it was 11. Just on the face of it, you can see that it's a big difference, but is it statistically significant at the 0.5 level? My guess is yes. So we leave the null the same. It's a right tail test because P1's greater than P2. And then we just go ahead and compute. So the Z to 2 decimal places is 7.80. Or the Z, the test statistic, and then the p-value is 0. So it is real significant. We're far below 0.05. The p-value is less than alpha equals 0.05, so we will reject. There is sufficient evidence to support the claim, which is in the alternative. Seatbelts work. That's question 9.1. Oh, there's one more question. Test a claim by constructing an appropriate confidence interval. All right, so here's what we do. We go back to StatDisk with the output, options, edit. And instead of hitting hypothesis, we want to perform a confidence interval. And the confidence interval is going to be an appropriate confidence interval. Well, since it's a one-tailed test, the 5% goes into the right. So to balance it, we got to put 5% in the left. So it's really a 90% confidence interval. So the 3 decimal places, the lower limit is 0.008, and the upper limit is 0.15. So 0.008, 0.15. I right away noticed that 0 is not in there. The confidence interval doesn't include 0, which means they're not equal. That's why we rejected the null. Because the confidence interval limits do not include 0, it appears that the fatality rates are not equal. Because if they were equal, then you would see 0 in the confidence interval. Because the confidence interval limits include only positive values, it appears that the fatality rate is higher for those not wearing seatbelts. Okay. So that's problem 9.1. Oh, one more question. C. What do the results suggest about the effectiveness of seatbelts? Well, we just answered that in the previous part. It's lower fatality rates. So it's number A, letter A. Okay, that's it. I will close this out. That's 9.1.13T. Dr. K is over and out.